This next example says solve the equation cosine squared of theta plus 3 cosine of theta equals 1 for theta between 0 and 2 pi. Give the answer in radians and round to 2 decimal places. Okay, the first thing you have to notice is that it's a quadratic equation. There's a square term right there. And everything is, the whole equation uses a single trig function. So there's no combinations of different kinds of trig functions. If there were, you would have to convert everything to the same type of trig function. So everything in terms of sine, or everything in terms of cosines, or everything in terms of tangents, whatever. This one is good to go. So it is a quadratic equation. We solve it like a quadratic equation. So first thing we want to do is move everything to one side. So we have 0 on the other side. So the equation is going to become cosine squared plus 3 cosine of theta minus, oops, this is a minus 1 equals 0. Okay, then if you can factor that, you would go ahead and do so. Otherwise, you'd use a quadratic equation. This one, you can check and convince yourself that you cannot really factor this. So what we're going to do is we're going to use a quadratic equation. So it's basically applying the quadratic equation to this quadratic polynomial right here. Right? So it's equivalent to solving this, where the u equals the cosine. Okay, so let's apply the quadratic formula here. So we're going to get u, which is nothing but the cosine. U equals negative b, so it will be negative 3 plus or minus the square root of b squared, so 3 squared, minus 4 times a times c over 2a. Okay, so that's just the quadratic formula from college algebra. Now we're going to simplify this. And what is that? That is negative 3 plus or minus the square root of, this is 9, and then minus 4 times negative 1, that's positive 4, so 9 plus 4, and then over 2, and simplifying this further, this becomes negative 3 plus or minus the square root of 13 over 2. So there's two possibilities here. So first possibility is the cosine of negative 3, the cosine of theta could be negative 3 minus the square root of 13 over 2, and then the positive is the other possibility. So cosine of theta could be negative 3 plus the square root of 13 over 2. So there's two choices or possibilities here. And like before, we're supposed to solve each of these. Okay, so from here, to get the theta, hit this with cosine inverse. So you're going to get theta equals cosine inverse of negative 3 minus the square root of 13 over 2. Okay, so let's put this in the calculator and see what happens. So you're going to get cosine inverse of, now remember you have to put a when you have like a fraction like this, you have to put parentheses around the numerator if there's more than one thing going on there. In this case, this numerator has two terms, so we really have to put parentheses. So parentheses are on negative 3 minus square root of 13. Close the numerator, divide by 2, and close that big parenthesis over there. And look at that. It says error, domain error. Domain error means that we entered something into the function that is not in the domain. This here is not part of the domain. All right, so this means there's no solution. It does not exist. In other words, no solution. Okay, to understand why that is, because it might be not very clear why that happened, why getting an error is totally fine, and that's because if you put this number in the calculator, let's do that just to show you. -3, oops. So numerator -3 minus the square root of 13 divided by 2. You see that number right there? The number inside these parentheses is -3.3. Now, you can only put inside cosine inverse numbers that are between -1 and 1. So the domain of cosine inverse, if you remember from that section, inverse trig functions, the domain is between -1 and 1. That means that if you try to plug in numbers that are not between -1 and 1, well, they're not in the domain, so it's nonsense, right? So that's why -3.3, since it is not in here, when you try to plug it in, you get nonsense. So the calculator will say error. So that's the explanation. Okay, so this cannot be solved. There's no solution from this part. So that side is done. Okay, now let's try to solve this one. Same way, same thing. So cosine would be cosine inverse of -3 plus square root of 13 over 2. Now let's plug this in. So this is going to be cosine inverse of, now don't forget about putting parentheses around the numerator, because there's more than one thing going on there. -3 minus square root of 13, close that numerator, divided by 2, and then the big parentheses. Oops. Maybe that was my mistake. Let's do it again real quick, my bad. Yeah, I entered that one incorrectly. That was my bad. Okay, so this is going to be 1.26319677. And by the way, I knew that it was wrong because I had already put this number, just this number, in the calculator beforehand, and you do get a number. That number inside the big parentheses is a number between -1 and 1. So you shouldn't really get an error. And let's do it real quick. This would be what? That would be -3 plus square root of 13. Take that and divide it by 2. You see, that's a number between -1 and 1. So I shouldn't have gotten an error. Okay, so this is the actual answer. So that's the first answer. So that's one solution. What's the second solution? For the second solution, remember how this goes. You have to draw the unit circle and figure out the second one. Okay, 1.26 is in what quadrant? Well, this is pi over 2, which is 1.57. This one is 0. So it is between 0 and 1.57. So it happens just coincidence to be again in the first quadrant. It doesn't always have to be in the first quadrant. That's just happens to be the case. But you always have to figure out what quadrant it is. So that's the first solution. The second one, since we're dealing with cosine, and the cosine has to do with the x coordinate, we want another angle that has the same x coordinate. Another angle that has the same x coordinate would be right here, right this one. That one. That's another angle that has the same x coordinate. And what's that angle? Well, it's almost a full revolution, so it's almost 2 pi, but you have to take away that piece, and that piece is the same as that because of symmetry. So and this piece is this number. So I'm going to take away this number, 1.263192677. Remember that typically we don't round off until we're done with the problem. So that's why I haven't rounded. 2 times pi minus 1.263 192677. 5.0 oops 019999263. Okay, so these are the two answers. We still haven't rounded, so that's the last thing we're going to do, round to 2 decimal places. So given the final answer, I would say rounding this to 2 decimal places, that would be 1.26, and the second one will be 5.02. Okay, and the last example that I have here is solve that equation. Solve the equation secant of theta equals -4. For this one, we're going to round to 4 decimal places. Okay, all of the equations that we have done so far have been in terms of either sine, cosine, or tangent, because those are the easiest trig functions to deal with. So whenever you have an equation that has secant, or cosecants, or cotangents, typically what is recommended is that you change everything to one of the basic 3, sine, cosine, or tangent. So that's what I'm going to do right now. Instead of dealing with the equation like this, that's not convenient. What is convenient is to switch everything to one of the basic 3. So what is secant? Do you remember what is secant? Secant is 1 over cosine. Okay, so I can rewrite the left-hand side as 1 over cosine. And then I can either multiply both sides by cosine of theta, or just take the reciprocal on both sides, works out to be the same thing. So if you multiply both sides by cosine of theta, right, multiply that by cosine of theta, multiply that by cosine of theta, you end up with 1 equals -4 cosine of theta, and now dividing by -4, you get that cosine of theta equals -1/4. That's not a special trigonometric value, so we need a calculator for this. To get the theta, hit it with cosine inverse. Let's see what we get. Cosine inverse of -1/4. And that's our first answer right there. Don't round off yet until we're done. Okay, and then to get the second answer, just draw your unit circle. Note, look at this one. This one is an example where it's not in the first quadrant. Okay, why is that? This is 0. This one is, remember, about 1.57. This is bigger than that. And this one here would be pi, which is, we'll know what pi is. Pi is about 3.14. So 1.823, etc. is between 1.7 and pi. So it is actually then in the second quadrant. This angle right here is in the second quadrant, so draw it somewhere on the second quadrant. There it is. So that's the first angle, the first solution. The second solution, because we're dealing with cosine, cosine is the x-coordinate. The x-coordinate, so another point in the unit circle with the same x-coordinate will be right here. Okay? So we're looking then for this angle. And what is that angle? Well, it would be, so this is one solution. So it would be, well, you past pi, how do you get that one then? You can figure out this one and then add it to pi because this piece is the same as that one. So that's one way to go about it. So let's do it that way. You see, if I need to figure out first what is this piece. This piece is, well, it is short of pi by this much, so I have to take away this much to figure out that piece. So the blue part is pi minus the green part. The green part is this. So pi minus that. And once I, so this is the blue part. Once I have that, that is the same as this. Okay, that is the same as that. So if I add it to pi, I get the answer I'm looking for. Note that this is the same as having 2 pi and subtracting that because it's the same as taking the whole circle, which is 2 pi, and subtracting this. And this is the same. You see, these two things are the same. That one is the same as that. So another way to look at it is to take 2 pi, which is the whole circle, and subtract this. So you would get 2 pi minus that. It really is the same thing. So whichever explanation you like best, go with that. So this is what? Let's put this in the calculator then. 2 pi or pi plus pi. Same thing. Okay. Minus 1.823476582. Okay, so there you go. 4.459708725. Now we are done. All you need to do is give the final answer, which is this, but just round it to 4 decimal places as per the instructions. So what is the final answer? X is either that one or that one. Round to 4 decimal places, 1.82355 or 4.4597. Okay, before I actually say circle this and say this is the final answer, one last thing. Note that there is no restriction. It doesn't say find all the answers between 0 and 2 pi. So that means I actually want all the answers. All the answers, not just the ones in the unit circle. So that means we have to add the 2 pi in because of the multiplicity. Any answer plus a multiple of 2 pi is going to work because if you do a circle of revolution, you end up in the same spot. You land in the same spot. So all these are solutions. Now that would be the final answer taking into account periodicity.